Okay, what I want to do in this video is to show you 3 examples of synthetic division. So our first problem is x to the 4th plus 12x squared minus 40x plus 25 divided by x plus 5. Now remember, synthetic division is something we can do when we have a divisor in the form x minus k, where k is just any constant. So in this case, our k is going to be negative 5. We have x minus negative 5. So let's set up the synthetic division problem. We're going to use negative 5 as our k, like I said, and then we're going to just use the coefficients of these. So the coefficient of x to the 4th is just 1. It's tempting here to put 12 as our next coefficient because we've got 1x to the 4th, 12x squared, negative 40x. But what's missing here? We're missing a cubed term. There is no x to the 3rd. Why do you think that might be? Well, suppose there were an x to the 3rd term, and its coefficient were just 0. So we have x to the 4th plus 0x to the 3rd plus 12x squared, etc. That's actually what we have here. It's just that since we have 0x squared, that's 0, so we don't bother writing it. But if we do have an x to the 3rd term, its coefficient is 0. So I'm going to put 0 down. Now we've got 12x squared, so I'm going to put 12. And then negative 40x and 25. Alright, so remember the process we learned in synthetic division. We're just going to go through that process. Bring down the 1, multiply the 1 by the negative 5 to get negative 5, and add these two terms, 0 and negative 5, together. That gives us negative 5. Multiply the negative 5 by the negative 5, and get positive 25. 12 plus 25 is 37. 37 times negative 5 should be negative 185. And then negative 40 plus negative 185 should be negative 225. And finally, negative 225 times negative 5 is positive 1,125. Plus 25 is going to be 1,150. So, the next step is to fill in all of the coefficients. So remember, the last term we get is always going to be our remainder. So we have quite a big remainder in this case, but that's alright. Now we're going to fill in our coefficients. We've got 1, so that's just going to be x to the... So we've got a 4th degree divided by a 1st degree. That's going to give us a 3rd degree, so our lead coefficient should be 3. I'm sorry, not our lead coefficient, the degree of our first term. So we've got x to the 3rd minus 5x squared, and now we just go on down x squared, x, constant. Remember, we can do that because we put this 0 here to make sure that it all fit perfectly. So we've got minus 5x squared plus 37x minus 225. And then our remainder is 1,150. And if we want, we can rewrite this as 1,150 over x plus 5, because x plus 5, remember, is our divisor. So remember, from arithmetic, we can just add the remainder over the divisor to the end of the problem. So that is what our final answer should look like for this problem. Alright, maybe this one will be a little easier, we'll see. We've got x squared plus 2x minus 168 over x plus 14. Alright, for this one, we're going to, again, use the coefficients and use synthetic division. So we've got 1, 2, and negative 168. And our k in this case is negative 14. Your k is always the opposite of what's added to x. So if you have x minus 14, your k is going to be positive 14. If you have x plus 14, your k is going to be negative 14. Alright, bring down the 1, multiply it by negative 14. Add these two terms together, we get negative 12. Multiply negative 14 by negative 12, and we get 168. Add these terms together, and they cancel, giving us a remainder of 0. That's always nice when that happens. And we're going to add our coefficients back in. We divided a 2nd degree trinomial by a 1st degree binomial. That's going to give us a 1st degree factor. So 1x minus 12, or simply x minus 12, and our remainder is 0, so we don't have to do anything more there. Alright, let's go to this third situation here. Okay, for this next example, I decided to write it down on a new piece of paper since we were running out of space. So what we're going to do is, since x minus 7 is our divisor, 7 is our k, so we've got 7 up in the left, and then our coefficients are 3, negative 22, positive 3 again, and then 15. First we're going to bring down the 3. This is what we always do. 7 times 3 is 21. Negative 22 plus 21 is negative 1. Multiply 7 times negative 1 and we get negative 7. 3 plus negative 7 is negative 4. And then we've got 7 times negative 4 is negative 28. And 15 plus negative 28 is negative 13. Alright, so negative 13 is our remainder. And then we have 3, negative 1, and 4 as the coefficients of our new trinomial. Now, one way to think about this is our last coefficient should always be a constant. It's just negative 4. Okay, minus 4. And then we just work our way up from there. So the next term should be first degree. So we've got negative x. And then the next term should be second degree. So we've got 3x squared. So 3x squared minus x minus 4. And then again, if we want, we can take this remainder and put it over the divisor. Plus negative 13 over x minus 7, and that is our quotient. That is another way to express this fraction right here. Hope all of these examples have been helpful, and I hope you get lots more practice at home. Thanks.